All right, we are here for the exciting second edition of How to Do Your Chapter 3 review. I have all my tools here ready, and I'm ready to rock and roll this thing. Let's see. I'm going to solve because it says so. And you know what else I'm going to do? I'm going to round to 3 decimal places because it says so. So I'm going to round, not just stop, which is called truncating, just for fun. And then I'm going to go to 3 because it says 3 because I don't like to lose half points. It's really annoying. So there's 4 methods for solving. You think if it's exponential, then if it is, you decide if they can have the same base or not. If it's logarithmic, then you isolate the log part and you check to see if there's just logs on one side of the equation or on both. And then there's a solving method for each. And lucky for you, this is from 3-4 on the day that I was absent. So there's a very educational video on that you can go back and look at those 4 methods if you're lost, confused. So this one happens to be a log equation, which I have deduced because it says log, I guess. Keeping in mind that I now need to write this in a different form. So this is like invisible base e. So I'm just going to do my good old log roll, and I'm going to end up with e to the 2x plus 5 equals e to the x minus 4, which will only be true since they have the same base if 2x plus 5 equals x minus 4. So if I take away an x from both sides and subtract that 5 to the other side, I get this. Don't get in the habit of deciding it can't be a negative because first of all, you got to check. I'm going to put -9 up in here and here. Neither of those forces me to take the log of a negative, so I'm good to go. And that is my answer. Do I need to write them on here? Probably I should. X equals -9. There. Okay, so I need to isolate the exponential part here. And so the first thing, know how to do the steps of these, whether they are numbers or not. Could be smiley faces. You have to be like, okay, I know PEMDAS, and I know that this thing, whether it's a smiley face or a 6, has to get subtracted to the other side. Then I know that whether it's an A, B, C, D, E, F, G, you know the rest, or not, this 8 has to be divided because it's attached by multiplication. So know how to do solving, whether you have symbols or you happen to have actual numbers, because we are brainiacs and need to know that. Well, you are. I'm just the teacher. So this, actually, I can think of as 3 to the 1. Then they have the same base, and I'm just solving 3x minus 5 equals 1, which would imply this, which would imply this. And it was not logarithmic, so I don't have to check my answer. There's no limitations on an exponential. Because if you remember, exponential has an unlimited domain. I'm sure that these are confusing. What you do when you have these is you think of the e to the x part, because that's what's making it confusing, and you let it be represented by something else. And I think I used a y in a previous video. So that would make this -11y plus 24. And this is going to be that squared because this would multiply the powers. So I would end up with a y squared. It just visually makes your brain happy. And then you can go, oh, what makes 24 in a way that adds up to 11? I think 8 and 3. To get -11, they both need to be negatives. And so then I let that equal 0. I know that y would have to be 3 or 8, but I let y represent e to the x. So that really means e to the x has to be 3 and e to the x has to be 8. So I'll do ln 3 equals x, ln 8 equals x. And I'm just rewriting that in log form because when I get an exponential, I need to use a log. When I have a log, I'll need to use an exponential. And then it did say round to 3 decimal places, did it not? So if I do ln 2, I'm going to round to 2 decimal places. Oh, hang on, ln 3, sorry. I'm going to get, as one of my options, 1.09. Now be careful, it says 86, so that 8 rounds to a 9. And for my second option, ln 8, it's going to be 2.0 7, and then this one is 9 with a 4 following it. So they don't round the 9, I just leave it as that. In the next one, these are not together. I need to condense them. So I would do ln of 8 over x has to equal 0. And that is a log, so I'm going to need to rewrite it exponentially. Since it's base e, I would have e to the 0 equals that. So e to the 0 equals 8 over x, but e to the 0 is 1. And the only way that is going to be true is if your x value is 8. Because 8 over 8 is 1. Hang on. We're going to yell at my dog because he's licking his leg and it's making me crazy. Boone. Hi. Stop licking. Thank you. He stopped. Alrighty. These need to be condensed. They're separated by adding. So I'm going to go ahead and put, don't forget the log base. I'm going to go ahead and put them together by multiplication. And I'm going to rewrite this with my good old log rule. 3 to the third. I'm going to just math in my head and get 27. And then here I'm going to have x squared minus 6x. That's a quadratic, and everybody in the whole entire universe, except for not most people, know that you have to get that equal to 0 to solve. And I need 27 in a way that subtracts to be 6, so I'm going with 9 and 3. I need a negative 6. My options are negative 3 or positive 9. And I do want to go check and see what happens when I go back up here. This is problematic. If you put in a negative 3 for x, you're going to be taking the log of a negative. So that actually does not contribute. And then if you put a 9 in, you're good. And here, 9 minus 6 is still a positive number. So that one is a valid option. And I get x equals 9. All right, here I need to get the log part alone, and so I'm going to get rid of the other stuff. So again, whether it's smiley faces, triangles, or squirrels, you just have to think of what gets moved first. This is going to get moved first. So now I have this. And I can just go ahead and divide the 6 out. So now I have the log part isolated, which is what you got to do. Get the log part alone or get the exponential part alone. And then when you're stuck with a log, you change it to an exponent. When you're stuck with an exponent, you change it to a log. So I get 2 to the 6th equals x minus 3. 2 to the 6th is 64. And so when I add that 3 over, I get 67. And certainly 67 minus 3 is still a positive number. Okay, this is a confusing part. For sure. This is asking you to find an exponential model. This is new. Like a lot of things we do, we have done in some form or fashion of the past. And this is actually brand new. And this is the one where it's similar thinking to when we do y2 minus y1 and so on to find the rate of change between linear points. But it's not linear. We're not looking for a common difference. We're looking for a common ratio. Because we're multiplying. We're doubling, 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 tripling, 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 or whatever the case might be. So we have to look at how do I find the A and how do I find the B in this value? These points here are a little bit confusing because if you were going to be graphing this thing, you would go to 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. 1, 2, 3, 4, and then up 1, 2, 3, 4, 5. And so it's exponential. It's going to be coming down from left to right. And so you have to kind of think about this x value in this problem and figure out like which one would actually be the second y. And it would actually be this 8, 2 because it's further down the road. Here's my 8, 2. Here's my 4, 5. And so in terms of like reading a graph from left to right, this is going to be the y2 and this is going to be the equation of y1. So when you're doing these, instead of trying to do y2 minus y1, you're doing y2 divided by y1. So I take, now that I wrote all over it and can't even see, I'm going to take that second point, and I'm saying second because it's further over. I'm going to put y in the y spot. I don't know a. E is a thing like pi. I don't know b, but I know that the x is 8. And I'm going to divide that second y equals equation by the first y equals equation, meaning first from left to right. So y equals a e b times 4. 2 divided by 5 is a decimal. A divided by a cancels. E to the 8b over e to the 4b, those subtract, and I get e to the 4b, because you're kind of canceling out. You have 8b's on top, 4b's on the bottom, they reduce or cancel. Then I'm going to ln 0.4 to get that power. So I had an exponential right here, so I unlock it using a log. Then I'm going to get my b value by dividing by 4. So I'm going to cancel that out. I'm going to go to my calculator and say ln of 0.4, close the parentheses, divided by 4. And I am perfectly happy to get a negative value for b, because in this format that we're talking about, I need a negative power for it to actually be decreasing, and it is when you plot those points in order. So what I do know is that my exponential model is going to be y equals some a value e to the negative 0.229x power, because I just found that b value or growth factor. So now I go back to either one of these equations and I plug that in to find the unknown a. I'm going to use the top one just because it has, I don't know, user-friendly numbers. So 2 equals the unknown a times e to the negative 0.229 times 8. That b value is no longer unknown. This, my friends, is all one number. So if I did e to the negative 0.229 times 8 power, this becomes the value 0.16009. And I would divide the two, or both sides technically, by that value. So if I divide 2 divided by that previous answer, I end up with an a value of 12.49, and then it is 27, so that rounds up to a 3. And I did absolutely not leave myself enough room. So y equals 12.493 e to the negative 0.229x. So I think that's going to be one where some people struggle a little bit because it's brand new. So make sure you've practiced that and you know what to do, because it's definitely going to be on there. Okay, half-life. Think about your half-life formula. What you have at the end is what you had at the beginning. It's half-life, so your growth factor is 5. You take your total amount of years, but you divide it by the length of a half-life. That's kind of how we've been doing those, mostly because that's the right way. Here it tells you the half-life of, what is that? I can't see that teeny number. Uranium-234 is 245,000 years. That's how old I am. What a coincidence. So that is going to be my half-life. What percent remains after 5,000 years? That's going to be my time. Percent is 100. So you either can put 100 here or you can represent it as a 1. It really doesn't matter. I usually use a 1, I think. So what percent remains after? So that's the y that's unknown. So I have my 1, I have my 0.5, I have my 5,000 years, and I'm dividing it into the half-life. So clearly that is not a half-life. So I should be much higher than 50% because it's only 5,000 years that have passed, and I need 245,000 years just to get down to 50%. So I don't have an unknown on the right, so I'm just going to type in exactly that big fat mess, making sure that the 5,000 divided by the 245,000 all ends up in the power. So however, you've got to do that. So I'm getting for y 0.98595, but I am supposed to answer it as a percent, so I got to scoot this back over. 98.595% if I'm still going to that third decimal place. And if I had put a 100 in here to begin with and worked the math out that way, this would have just come out as 98.595. So it doesn't matter. Here I'm starting with 5, so that's A. How much remains after this amount of time? So again, it's me finding y. So I started with 5. I'm still doing half-life. A little more time has passed, but certainly still a drop in the bucket of our 245,000 years. Because if you're just 9,000 years old and you got 245,000 years to go, that's just like being a toddler. But it's the same process as the previous one because everything is there. I just do the 5 parentheses. I'm going to type in exactly what I see on my paper, or technically on my notability. This is a pretty fun Friday night, actually. I hope you guys are at the game, probably freezing your butts off. 7, 4. And this is a word problem, my friends. So when it says, if you start with 5 grams, how much would remain? This would be grams. Don't lose a half point. Half points get really aggravating. 5-gram sample, so that's my starting amount, has decayed to a 3-gram sample, so that's the end, in 4,224 years. That's my time. What is the length of a half-life? So I'm looking for that half-life. Alrighty then. So I'm ending with 3. I'm starting with 5. It's a half-life problem. I'm going to have my time, which is 4,224, divided by half-life, which I don't know, so I'll call that x. All right, let's solve. Starting by getting rid of this 5. Somebody just came to the door, so I was waiting for a lot of barking. So 3 divided by 5 is going to be 0.6. And then I'm going to have, I wonder if it was the Amazon guy. It's probably my 30-second dance party button. I'm so excited. Okay. Now I can't concentrate. 4,224 divided by x. Okay. So I have an exponential. I can't undo it from here, so I need to rewrite it as a log. Log base 0.5 of 0.6 has to equal the power because the power always stands alone. So the left side of this equation needs to be done on my calculator, and I did that before and got 0.737. I do not have enough room. And so that's going to equal 4,224 over my x. So you can math this out however you want. If you want to think of it as cross multiplying, you can. But ultimately you have 0.737x equals 4,224. You go ahead and divide, and you come up with about 5,731. And then if it's still a to the nearest 3 decimals, 343 years, because it's measuring the half-life. So that's how many years it takes for half of that carbon-14 to decay. I don't love graphing. All right, let's do it. So it says graph. Label your points, which to me that just means make sure there's couple specific points. We need domain, range, and asymptotes. Okay, pay attention. Are they logarithmic or are they exponential? And know what that means. Know what that means in terms of asymptotes. Know what that means in terms of shape, all that good stuff. So I'm going to go ahead and take a look. This is log. So if you want to get a couple points, you got to choose wisely. Keep in mind that log graphs have a vertical asymptote at 0 unless there's left-right shifting, which this one doesn't have. And it's going to be on the right of that. So my domain is from 0 to infinity. The range on these is always all reals. And my asymptote is a vertical line at 0. Now I need a couple specific points. Let's say that my x was 1. This would be asking 3 to what power is 1? So 1, 0. How about, I want to put a number in here that makes it easy, so I'm going to also try a 3, because that would be saying 3 to what power is 3, and that answer is nice and clean. So 1, 2, 3, up 1. I have a couple of specific points labeled, that's what that means. You have to actually label them. And then my graph goes along the side. There's no transformations there. A part of the test is going to ask you to describe the transformations, but there aren't any. Here I have another log graph. It's still base 3, but this is going to move to the left 4 and down 1. So that would be my description. And I would go ahead and move everything to the left 4. So the most significant thing about that is that my vertical asymptote is now located here at x equals negative 4, 4 to the left. So my domain now follows that, and my range never changes. For log graphs, it's always all reals. Okay, so I'm going to be doing 3 to a power. So I want this thing to be something that I can make, like figure out the power. So if I did a negative 3, I think I tried. And the reason a negative 3 is helpful to me is if I put a negative 3 in for x, negative 3 plus 4 is 1. And then this part is asking me 3 to what power is 1. And so then I would have to the 0 power. So at negative 3, oh, I'm sorry, that part's 0, but then there's a minus 1. So I would actually be at, oops, it erased everything. I'd actually be at negative 1. Just the part I circled comes out to be a 0. Okay, what if I put in a negative 1 for x? Because if I put in a negative 1 here, negative 1 plus 4 is 3, and this part would be asking 3 to what power is 3, and the answer to that would be 1, but then I'd subtract 1 and get 0. Oof. So negative 1, 2, 3, down 1, and negative 1, 0. Thankfully, I have an idea what a log graph looks like, and I can come up along the asymptote and shoot out that away and not have to do more thinking to get more points. Here, I'm looking at exponential graphs. How do you know? Because the x is in the exponent, thus the name. This is pretty generic. E is a value greater than 1, and so this is going to be exponential growth. So get your brain in that spot. That means I have a horizontal asymptote. There's been no shifting up and down. So my asymptote's located at y equals 0. Now, the graph is going to occur above that. So my range is going to be from 0 to infinity. And on these, the domain is all reals. So you have to kind of keep that straight. For logarithmic equations, the range is all reals, but for domain, for exponentials, it's the domain that's all reals. Because remember, these swapped, the x's and y's, because they're inverses. So e to the 0 so if you want to do a little table or write it on your paper or just think about it, e to the 0 will give you a 1. So I know that 0, 1. And then think about 1. E to the 1 would be e, which is 2 point somebody or another. So I'm right here at 2.7-ish. And I know that this is exponential, so I know it's going to scoot in here and then shoot up. So I don't have to be able to plot a ton of points, just enough to get that going in the right spot. Now, what about this? Transformations. This is going to be 1 to the right and 2 up. The 2 up is significant because that moves my horizontal asymptote up 2. So now I'm at y equals 2, and that's going to push my range up above 2, because if you push that floor of the graph up, it moves with it. But my domain will remain all reals because it always is for the domain of an exponential. And then I'm trying to get like 2 points maybe. And so I'm going to start with a 2, because if I put a 2 here, e to the 2 minus 1. Oh, actually, I'm going to put in a number that makes my life easier. Let's say I put in a 1. Then I would have, erase, e to the 1 minus 1. But that would be e to the 0, which is 1 plus 2 is 3. Okay. So then what if I put in a 2? Then e to the 2 minus 1 is going to be e and then plus 2. So if e is 2.7-ish, when you add 2, it's 4.7-ish. So I have a point at 1, 1, 2, 3, and 2, 1, 2, 3, 4, almost 5. And I know it's exponential growth, so I follow that asymptote. I don't cross it, I don't touch it, and then I go swinging up. Okay. Then I'm quitting at the end of this page, and then I'll do another one for the other, because I gotta take my dogs out. In 2005, a population, Arnoldton, okay, Miss Arnold must have made that up, was 230,000. So this is my starting value. This is my starting date. So if I let, this is going to be like implying that X is going to equal years since then, since that. So it's going to be years since 2005. The population is growing at 1.5% each year. Write an equation. You know what an equation has in it? An equal sign. Okay, so let's think about this. So my population based on X is going to be my initial population. And then if it's going up at 1.5%, you have to move that decimal over, but that's getting added to the people that already existed. So my B value is actually going to turn out to be 1.015 to that X power. And it's really not asking me to do anything, and I don't really care. You can write Y equals F of X equals P of X for population, whatever floats your boat. And X is representing years since 2005. So here, when it wants you to approximate the population in 2015, you have to think, okay, 2015 minus 2005 is 10 years later, 10 years after that. So I'm going to put a 10 in. So if it says on the test to show your setup, what it's looking for you to do is show that you took this, and then you took this to the 10th power. So I'm going to do that. And I already did that. So I'm going to just copy my answer because we don't have all night. Well, I do, but you probably don't. I'm going to go with this. And I get it. I get that you feel like you shouldn't write 0.390 people, but it's just an estimate. If it doesn't say to round to the third decimal, I'm not going to be particularly picky. But you do have to label what it is, because maybe that's that many bananas or that many oranges or that many bowling balls or that many rotten eggs. So you have to tell, the reader that that is people. Oh, look at this. We're going to do some backwards learning here, but we are not graphing. What year, 3 decimal places, there we go, will it reach 250,000? So this is the after. Like after how long will it be at 250? So I'm going to put 250,000 out here. I started with 230,000. My growth factor is 1.015, and I'm trying to determine the time. First thing I'm going to do is divide this out of there. Gone. And this, when I divided it, was 1.087 something. And that left me with 1.015 to the X. So I have an exponential and I'm stuck. So I need to rewrite it as a log. Log base 1.015 of 1.087. And if you don't have a calculator that allows you to plug it in, you have to do log of 1.087, close the parenthesis, and divide by log of 1.015. I'm at home, and at home I have one of those like fancy ones that does that for me. And so and that's going to equal X, sorry, because that's going to be the power. So when I did that, my estimate was 5.603. So it asks what year. Oh, okay. So I actually have to add that to my 2005, which was the starting year. I wrote on my answer key 5.603. So that actually is not the perfect answer. So make sure you read if it says like in how long, or if it says when or during what year. So my answer is like 2010.6. So that means that it does happen in 2000 like a little bit after 2010. So I guess I would write something like in 2011. But that is why having your work shown helps a ton, because then if you like write something weird for the year, I can see all of your work and see that you know what you were doing right up to that point. Okay. I guess I'll go through a couple of these. Is there ACT on there? No. The idea of the ACT practice is to give you an idea of like what does it look like when they ask ACT questions. So for these, this goes back to graphing again. This is a log, exponential. It's asking for the domain. So think about that. The domain of an exponential is always all reals. So this part C is part of always. The log one is going to be tied to the vertical asymptote, and you only get a change in the vertical asymptote, having trouble talking, if you shift left and right. And the 7 isn't going to do that. It's going to shift it up 7. So since you didn't move the asymptote, this is going to have its normal vertical asymptote at x equals 0. So your domain will go from 0 to infinity. This one has been shifted to the right 1. And so my vertical asymptote is going to be at x equals 1. So my new domain is going to go from 1 to infinity. All right, so multiple choice ACT type question. For what value of x is this equation true? Well, they have it set up where the bases are the same. And so I can just cancel that. And you are left with 2x plus 7 equals 15. So then 2x must be 8. So then x must be 4. There it is. So there can be some fairly straightforward problems, but a whole bunch of kids, A, never get to logs in their math career, or B, get to it, forget it, and can't recall what to do on the test. So just kind of try to log away some of this information in your memory. Pun unintended. Okay, which of the following expressions is equivalent to this thing? Keep in mind when we have fraction powers, the top is the actual power and the bottom is the root, like a plant. The root goes in the bottom. So if I rewrite this, it's going to be a cube root. Oopsies, it should be the cube root of that x, but then squared. Or you can also write it as the cube root of x squared. And what the ACT is getting at is, do you know that all three of those things are equal? And so they will never give you, obviously, more than one choice that's correct. So they chose to write it this way. So my answer is going to be E. Okay. Number of decibels, blah, blah, blah. Okay, whenever there's a lot of words, what I do is I look for the equation. They're going to tell me. I is the intensity, K is a constant. How many decibels, so that's D, are produced by an audio source whose intensity is 1,000 times K? All right. So if I'm using that formula, the decibel level they're looking for is going to be 10 because that's in the formula, the log. And then they just told me that the intensity, which is the top, is 1,000 times greater than the bottom. So if I make the top 1,000 and it has to be 1,000 times greater than the bottom, that's just going to have a bottom of 1. So I'm going to my calculator and typing in 10 log 1,000. And I'm getting 30. So that's this. Physics. Okay. Do I just want to make myself do this? I suppose. I already did them, thankfully. So what do I need to do? It shows the yield in milligrams, so that'll be important for me to think about later probably, of a chemical reaction after X minutes. Use the regression feature to find, and now pay attention to what it tells you to do, log and linear. Okay, so linear, remember, is going to be, I think it says linear regression. I think it'll give you linear, and then it'll show AX plus B, but log is ln regression. So keep that in mind, that a logarithmic is going to be ln. So I entered these. So remember, you go to stat, edit, put these into L1. Stat, edit, put these into L2. If you want to be able to see, here I'd probably go for an X min of 0. And for now, I'll go to an X max of 10. Here, I probably used a Y min of 0 and went to a Y max, probably I went to 20. That'll show me what I need to do. And then once I have my numbers in, I can set my window, get my plot on, and then go ahead and hit enter, or graph, and I'll be able to see it. Then I can go to my stat again, but now I'm going to calculate, and I'm going to calculate whichever of these you want to do first. So this is log, so I'll look for ln regression, and it writes it in the form like a plus B times ln x. And so it tells you what the A and the B are. So when I do this, keep in mind I'm writing an equation. It tells me that the A is 1.538. So I'm using 3 decimal places because it'll say that on the test. And then it tells me the B is 8.373 ln x. It shows you like the format, and then it tells you the pieces. A is this, B is that, and you just write them in. Okay, and then the other thing I would be prepared to write down on my test and recognize is what that R value is, remembering that the closer it is to 1, the better your equation, like the log equation in this case, the better it fits the data. If it is 1, then it goes right through every single point, and it's a perfect fit. Linear. Okay, I just go back, I leave my points in the calculator, I go back and I do stat, calculate, linear regression, and then it'll kick out my A. It'll say y equals ax plus b. It'll tell me my A and B. So I got 2.289x plus 2.336. Double, triple, quadruple check your answers, or I mean the numbers you put in, because if you put any of these numbers in differently than I did, you will get different numbers and your equations will be wrong, which will then make your predictions and everything around it wrong. I jotted down my R value here as well, and this one was 0.949. So when it asks me which model fits the data best, I went with the one that had the higher R value. I had an R value here of 0.9967. So comparing 0.9967 to 0.949, I'm going to go with that log equation fitting the data better. Okay, and then in the last one, I'm looking at defoliation caused by the gypsy moth. I hate that when that happens. I'm reading. It says logistic model. We haven't done a ton with logistic model, but let's kind of recall that the logistic model is the one that goes zoom. Oh, you know what? You should go back and you should finish number 27 through 32 on the 3.4 to 3.6 extra practice, because that is the one where you match all those different kinds of growth models, and you'll need to do that on the test. I mean, you didn't hear that from me, but you will. Okay, so I'm going back, I'm clearing out my old numbers. So I go up to L1, I hit clear enter. I go up to where it says L2, I hit clear enter, and it's cleaned out. I enter these numbers for my L1, these numbers for my L2, and I do logistic regression. Now, it gives you all the crazy business, like this is a C value, and this is an A value, and a B value, and it tells you where they go. I don't have room there because I made the chart too small. So I ended up with a graph that looked kind of like this, and then it had a point, and then a point, and then a point. So my logistic was going to come in here and then swoop up there. When I did the equation, it gave me a C value, which was like, I feel like that's not right. Oh, I was thinking of the one that was on 3.6 where I got like 9,999. Okay, sorry. Told me my C value was 99.746. That top number becomes your limiting factor. So my guess is the limiting number on that is 100, that you're approaching 100. It's kind of that upper asymptote that I talked about with these. Then the 1 is part of the formula. It gave me this number to put in here. And then e to the negative 0.069x. So it gives you all these numbers. It gave me this number, it gave me this number, it gave me this number, and I'm good to go, and I just can't fit it on the line. How closely does the model represent the data? So what I did is I went to Y1 and I typed in that equation and I hit graph, and it went zoom, 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 and it basically went right through there. You notice that you don't get an R value with logistic, and so you can't use that to measure it, but it was very closely. I mean, it looked to me like it was going through everything. And I was so excited to get to this problem because it's the last one, and I know that you have done your due diligence if you've gotten this far. Okay, now they're giving you 80 80 egg masses. What? Who knows what's going on? And it asks me to approximate the percent of the defoliation. Okay, well, the approximate percent of defoliation is going to be a Y, which means this is an X because that's egg masses. So I actually just need to plug it in. If you've typed this into Y1, you can just go second and then go to window. That's going to be that table set, and you can just do table start, and you can say, hey, start the table at 80. And then when you hit second and the graph button, it'll go ahead and show you the table of values, and next to the X in your table will be the Y, which is 96.984, and that is a percent because the numbers in that column are percents. And you're done. So definitely go do this so that you feel confident about the matching. And this is so long, but I got to tell you, and I've said it numerous times just to make sure I can say I told you so. Why didn't I put an answer here? Oh, because I didn't have room. This is my answer. So this is long, the test is long, because you're supposed to be able to buzz through, like rewrite, solve, you need to slow down a little bit, expand, maybe, condense, kinda, but you do need to be able to kind of buzz through a lot of this and not be thinking really hard or trying to figure it out because you're gonna run out of time. So you gotta be like, oh, I know how to do this. I'm gonna go for it. I hope you have a fantastic weekend, and I will see you later. Bye, guys.